So I think we'll start the session, just introduce ourselves. So I'm Andrew Dudley. I'm the area sales manager for Trotec Laser in Ireland, based here in our Dublin showroom. And Jonny is in our Loughborough, easy for me to say, showroom, looking after the east of the UK.
Absolutely. So yeah, here we are in sunny Loughborough. We've got one of our SpeedMarker galvanometer lasers to show you today. Very different animal from the plotter type machines, but we'll go into that a little bit more later. So I believe Andy's got a bit of a presentation to run through, and then we'll show you some lasers running.
Yeah, we have. We've just got a couple of slides. We're just going to dip into it and dip out of it, I think. But we're going to excuse me. We're going to show the SpeedMarker running as quickly as we can. So a little bit of an overview of what a Galvo is. So basically a Galvo is a very fast engraver. So the idea is why you might look for a Galvo is that it's incredibly quick engraving of items. And potentially this could be at least 10 times faster than a plotter laser. So even the Speedy 400, a Galvo would be potentially 10 times faster at engraving. You typically have Galvos. So Galvos are typically with fiber laser, but we also do CO2 as well. But you mainly see them with fiber applications marking directly onto metal, and that's why you get a fiber laser is a very long-lived laser. So generally, once we put one of these machines in, we don't generally hear from them too much afterwards in terms of technical issues on the hardware. It's very powerful in terms of the software it can use as well. So we can integrate it into production lines. So that's one of the main features of the galvanometer system. You can link it with your data, your information system, so it can pull down serial numbers, dates, voltages, pressures, whatever sort of information you want on either a part or on a plate, and it can bring that all in variable data and mark that in sequence.
So sorry, go on.
Sorry, yeah,
no,
if you want to pass in, mate, you know more about them than I do.
I was just going to say the main reason why a Galvo laser is going to be faster than a flatbed laser is because on a flatbed laser, as you've been seeing the last few days, you physically have to move the final optic around the working area and scan it over where you're working. But with a Galvo laser, it's just two very fast electrically operated mirrors that we can zip around anything up to 10 meters a second. So we can really zip around the working area, even if we don't get as much working area of one of these machines as you would on a flatbed.
Yeah, exactly. And this is just a little diagram just to show you of what's sort of inside the Galvo laser. You've got those galvanometer motors, which are really fast motors, but they only really need to move very small angles to adjust the laser beam width, and it passes through a special f-theta lens so that the engraving area is all in focus. But that's probably enough technical. We want to actually have a look at the machine in action. So
absolutely,
what we're going to do is going to go to Jonny, and hopefully everything will run smoothly.
No problem. Well, thanks, Andy. Thank you very much. Let's just grab my other camera, and we will have a little chat on the Galvo machine. So
while Jonny's changing that, I'd just like to say we're going to try and run it as a demo. So I'm going to ask Jonny some questions. Now I obviously know potentially what questions to ask him. So if there's anything else that you want me to ask, put it in the chat, and I will, even if it's not about a Galvo. So again, if it's about his favourite football team or whatever it is, he's quite happy.
Don't open that can of worms here. Rightio. So I will.
Okay, I'll just drag that. That's fine.
Thank you very much. So let's just drag this one out the way. Right. Okay. So what we have here, this is a SpeedMarker 300. Now, what a SpeedMarker 300 is a Galvo laser with this one 20-watt fiber laser source. So as per Andy's presentation, we have a fixed laser head. There are two steering mirrors in here. We'll go through an f-theta lens. Now, what an f-theta lens is a kind of fisheye lens. It's similar to the lenses you'll have, that estate agents will have on their cameras to make your spare bedroom look massive. But basically, it brings the corners in a little bit closer, so we get a nice flat marking field. So even in the corners, we're not going out of focus. We've got a nice usable flat plane that we can engrave on. So this particular one, as I say, 20 watts of fiber laser. 20 watts doesn't sound like a lot, but 20 watts, if you can deliver it in 100 nanoseconds, is quite a big deal. So we'll be able to engrave pretty much anything metallic that you like. So how we set the machine up.
What have you got for us? Let's have a look at it going.
Let's have a look at it going indeed. So we're just going to put in a little piece of anodized aluminium.
Very nice.
So if you can see, let's go to our other camera in the machine. That'll be easier to see what's going on.
Yeah. So basically, as Johnny's got that set up there, we've got a little webcam. There we go. Perfect.
So there we go. Now hopefully you can see we've got two little red dots there.
Yep.
Can we see that? Cool.
Yep,
so those two little red dots are our focus lights. So when you bring those together, then the laser is going to be in focus, and we know we're going to get a usable beam out of it. One of those beams is just mounted at the back of the machine, but one of them is going through the same mirrors and lens as the actual laser itself. And so because of that, we can use it to project where, let's turn the light off, be easy to see. So you can project onto the workpiece. You can just about see that, where the actual mark's going to be. So we've got a little red square.
So this is a bounding book with the graphic.
Yeah, and all that is the laser actually drawing out where it's going to be. So it's going through the same mirrors and lens as the actual laser beam itself will be. So we know it's going to be exactly in the right position. So as we've been alluding to, Galvo lasers are very, very quick. So what I'm going to do is I'm just going to press this button here.
And it's done.
And in 2.3 seconds, we have our lovely logo. Exactly. So anodized aluminium, a very nice, easy material to work with these kind of machines. So hopefully that gives you an idea of the kind of rate of performance that we can offer with it.
Yeah, I usually when I do a Galvo demo, I get the customer to press the button to go, and then I say by the time you look at the working area, it will be finished. So it's usually quite good.
I always say you're going to be longer putting things in and taking it out of the machine than it actually will be processing it.
Yeah.
So,
yeah.
But you're more than welcome to come and press the button if you want, mate. I mean, I don't know what the flights into East Midlands are like at the moment, but well, it's going to be a long demo if we do.
It'll be at least 2 weeks by the time I can get to you. Yeah.
This is going to be a long stream, ladies and gentlemen. So
exactly. Yeah. Okay, so we've had a few questions in just while you're setting up the next one. Somebody's asked about Daniel's asked about the beam size. It's not necessarily relevant for these machines, but this is the Speedy 300, 400, 500. This does depend on what lens you have. So you're looking at sort of about 0.13 of a millimeter or 0.013 of a millimeter, sorry, and upwards. But yeah, we might come to that in a second. Lothian Woodworks have asked a question: what's the biggest work size you can get on a Galvo?
That's a great question.
Where we can have a chat about the lenses.
Absolutely. So let's just run this other piece off in here, and then we'll have a chat about that. So what I'm going to do here is just a very quick 2D data matrix barcode. So we'll fire that onto a bit of stainless steel. So that's a great question, Lothian.
This is the problem with the Galvo demos; they don't take long.
So the working area on it is a factor of what lens you use, because the working area will come down in kind of like a cone from the lens to reach its focus point. So this lens is 160 mil in terms of its distance from the workpiece, but the actual working area is around about 120 mil square on this one. So just done a little 2D barcode. As you can see, what we've done around the edge, we've just put a little neutral zone as well, just a cleaning pass. So that's what the lighter bit of that is. Just in case you've got a very reflective or shiny or textured surface, it just gives a nice neutral area that you can read your barcode very, very easily from.
Yeah, and this helps the barcode readers read the barcodes effectively, doesn't it?
Absolutely, absolutely. And while there's many different types of barcode readers in the world, I'm sure a 10,000-pound barcode reader will read just about anything. But if your barcode reader is a bit rubbish, then it really does help. So in terms of working area, then. Yep. Sorry. Let me embiggen myself a bit. Okay, so This is what one of the lenses looks like. One of these guys. So the one in the machine is the 160. This guy here is a 254 lens. So it's going to be 254 millimeters focal distance from the lens down to what you're working on. This one will give a much larger square of operation. So this one, you can get about 190 mil square. However, the trade-off is it needs to be far further away up here to what you're marking. So your available height of the products you can get in the machine is going to be much lower. So it's always a trade-off. You're going to get a bigger marking area, but in terms of the height that you can utilize in the machine, it's going to be a lot less.
So this is certainly relevant. Sorry, I'll just bring myself back on screen. This is certainly relevant for the SpeedMarker 300 because it's a fixed position. Whereas what we can do in the larger SpeedMarkers, so the 700, 1300, 1350, and the 1600, we can actually move that head position. It can index in different positions on the bed, so we can actually make that marking area a lot larger as well. So, and they've also got a bigger height as well, so you can use those different lenses and not have so much of a sacrifice on the thickness of material.
Absolutely. No, it's all just having it set up for what you want to work with. Because while the working area on the one we've got at the moment, 120 mil square, it's going to be fine if you're just doing little plates. But if you've got a bigger object, then you might only be able to mark it in the middle of the field. So yeah, it really is just how big your marking area is and how big the inscription on it needs to be to go onto that. Okay. So.
Yeah, we've had a
Let me just get quickly set up on this end for the other part of the demonstration.
Yeah, that's fine. So while Johnny's just setting up the next part, I've got a few material samples to show you on the slide. But Graham has just said I don't have a need for that Galvo, but I want one now. That is every time I see a Galvo used.
Disagree. Everyone has need for a Galvo.
Everyone has need for a Galvo.
I'm not an unbiased actor in this, but. Yeah, exactly, it's certainly my opinion.
So Phil has also asked, we are interested in a Galvo head machine for paper cutting, ideally with a camera system to read registration marks automatically. So Johnny, what do we have to offer?
So for paper, we're not going to be using a fiber laser like this one. As per the demonstration the other day, we have fiber and CO2 versions of Galvo laser machines. So we're going to be looking at a CO2 machine for that. In terms of automatic referencing, certainly nothing's impossible. We've got an automation division over in Germany who take on special projects for us in barcode entry, specialized delivery systems, etc., etc. So certainly nothing beyond our capabilities. So yeah, be interesting to kind of explore that a little bit more and see exactly what it is you're looking to get to.
Yeah, absolutely. I think the models we generally have the CO2, certainly paper and card cutting, Phil, are the GS 1000 and that range of machines. So definitely get in contact with us and we can have a chat to you more about that one. So I just add this back in. Here we go. So moving on from that screen, we've got a few sample applications. I'll just make that a bit bigger so it's a little bit more visible. Oops, sneak peek of the next one. There we go.
So we're excited about that one.
Exactly. Typical applications that we might have with Galvo dumpsters. So this is based on maybe what we see our customers are using it for in the real world. So it's part marking is one of the big main factors in a galvanometer. Again, marking onto metal parts with that data matrix code or a serial number, as you can see there by the sort of bearing type image at the top right, and also then the saw blades. You can see that we can get a very accurate and very detailed information onto a part specifically.
It's very extensively used in very extensively used in kind of industrial marking, because unlike printing it on or any other like stickers or tapes or anything, you're not applying it onto the surface, you're physically changing the surface. So it's going to be there for the lifetime of the part. You have to really physically remove that top layer of material to get rid of the mark. So oil and gas, aerospace, automotive, all kinds of industries where permanent part marking that needs to last decades is required, and these kind of machines are ideal for that.
Yeah, exactly. So anything automotive, anything aerospace, it's something that they use extensively for. It doesn't have to be metal though. So the fiber laser in general can work with plastics as well. So as you can kind of see there, there's a nice color change on the black plastic part in the middle with the white text. You can
I just have a quick chat on fiber lasers while we're talking fiber lasers?
Oh, go on then. I'll bring you back in.
All right.
Where are we?
Fiber lasers are a really wonderful metal marking technology because fiber lasers have a much longer pulse than older similar technologies like YAG lasers, vanadate lasers, that kind of thing. They might be 10 times longer for each shot of the laser. So consequently, you're doing 10 times more work on the material and getting deeper engraving much more quickly. They're also far more efficient in terms of power usage and don't require any real servicing, as goes the laser source itself over the lifetime of them. So they're really lovely bits of kit.
Exactly, and we've also got the we'll maybe come on to the MOPA in a bit, but that is a module that we can get on the we can put onto the fiber laser, which can create different results. Certainly, annealing anodized aluminium. Sorry, not anodized aluminium, annealing aluminium, and also extra different results on plastics and metals as well, and also color onto steel, which is pretty cool. But again, just going through these while Johnny's setting up, I think he's ready, so we'll crack on. But ratings plates. So this is a very typical application on the ratings plates on the right hand side, both alphanumeric and QR or data matrix codes. Again, component marking, but then also so that's more of the industrial side, I suppose. When we go to more of the personalization and gift marking, again, something that maybe people might use a flatbed or a plotter for, but they're looking at a Galvo for increased production speed, maybe increased usability as well, or one-off. So it really lends itself to a small run bespoke items. And certainly if you've got a large marking area, the back of the watch, for example, again, it might be 10 times faster on the galvanometer machine than a plotter machine. So getting those jobs out quickly is paramount. You've also then got we sort of worked our way around clockwise on the samples. We've got the rings, so inside and outside of ring. So rather than sort of talking about that too much, Johnny's actually got one set up in the machine, as you can see.
I have indeed a highly valuable precious metal that we're going to be engraving today. This is a pack of 20 brass plumbing rings I got from the local hardware shop for about £1. So astonishingly how few jewelers want to chuck like 20 gold rings at us for sample exercises. It really is weird that. But we are set up with our rotary chuck here. So what we're going to be doing is we're going to be engraving around the outside diameter and the internal diameter of this ring, because the Galvo, the beam isn't coming just perpendicular to your material like it would be on a flatbed machine. It's going to be coming in at an angle. Now we can utilize that by firing it in at an angle and getting in here. So we're going to do just that. So we can, instead of projecting on the whole shape of it, because it goes around the whole face, what we will do instead, if we can see that, is, it's quite difficult to see, we're projecting on a crosshair, so we can just see the center of each segment. Segments are important. Unlike the flatbed machines where the rotary fixture is going to be spinning gradually all the way around, Galvo is a bit different. Galvo is going to be just doing it in segments, so it's going to do a little bit of the marking, move around a bit, do a bit more, move around, do a bit more, like that. Because the Galvo is so fast acting, it needs the part to be very still and stable under it, otherwise the laser is going to be zipping all over the place and it's not going to look good. So
yeah,
we'll shut that down.
It's too fast for the rotary, so we need to do it in segments. Yeah.
So, and off we go.
So what's he engraving on that one, Johnny?
We are making a discount replica Lord of the Rings One Ring. I'm not sure what it says in Elvish, but
no, I think you have to read the book for that.
I think it says visit troteclaser.com for all your laser requirements.
Yeah, you'll have to scan it with a reader and it'll say that. Yeah. so that was quick. As expected.
That was quick. That was just under 30 seconds, and the majority of that is obviously with it moving rather than actually firing the laser. So it's kind of dictated by the speed you have to spin it rather than anything else. So there we go. Let's give that a bit of a wipe before I show the world.
Exactly.
So there we go. So if we go on, mate.
Yeah, just angle it. Yeah. Okay, there's a bit of light in there. It's a bit difficult
Focus,
to see.
please.
Yeah,
we're much better at focusing lasers than cameras here, as you can see.
Hopefully.
Let's put it back a little bit.
I was just going to say, you can see on the actual rotary duck itself, there's a bit of fiber marking. So we use it for our own products as well.
Yeah, we're really struggling to get that on focus, aren't we?
Oh, there we go. Yeah. And now you moved it.
There we go. Right. I'll tell you what I'll do, I'll put it back in the fixture, then you can kind of see what it looks like from there.
Looks like as well.
Yeah, so what we're going to do now, we're going to do the inside of that.
So how are we able to do the inside of the ring on a Galvo? What's the difference? Because I know on a plotter laser, we've got a vertical, it goes straight down the laser beam. That's a little bit different on the Galvo, isn't it?
Absolutely. And Kate, you're more than welcome to have it. I'd be delighted for you to have it.
Send us your details and we'll post it out to you.
And ironically, yes, if you really do want it. Right. Yeah. So how are we going to get the engraving into there? Well, as I say, the Galvo, the beam isn't going straight down. It's going in at an angle.
So Phil's just said that. Yeah.
So
sorry.
Just to give it a little bit of help, we will angle it up. So we're just going to give it 10 degrees of angle, just to give it a little bit more ability to get in there. So just 10 degrees of angle on the chuck, just so we can get in a little bit more and see the inside of that. So this is kind of why, if we pull the camera back, this is kind of why we set the rotary over at the side anyway, because we can do our rotary work. That's great, and we can also work on the flat without fouling on the rotary. So we can drop our laser head down, focus on the flatbed, and not foul on the rotary at all. So we can leave it set up simultaneously, and then when we want to use the rotary, not only can we go around the outside, we've also got the ability to go on the inside too. So that's why we normally set the rotary way over to the side like that.
Perfect. Got your nice camera stand there.
Absolutely. Right, so let's go into there then. So the reason we're doing a nice shallow angle like 10 degrees is because we want the laser to stay in focus. So if we angle it up at some silly angle, then the laser might not be focused over the entire patch of the engraving. So we want it to be nice and even throughout. So just the minimum we can get away with, really.
Okay. And is that 10 degrees fairly standard on most diameters, or would that might change depending on what object you have?
Really does depend on what object you're looking to engrave. So if it's something very thin that you can just get in on the flat, always better to do it on the flat. But if you can't quite reach, just to stop it just hiding behind the top there. So we don't want this to obscure the lower bit that you're trying to engrave. So just so we can see from the middle of the lens into there, that's all we really need.
Perfect. Okay.
So let's run the other side of it then. So again, a little tricky to see at times, but there is much better without the light on this, actually. There we go. So we can just see again, we've got a little crosshair in there, so we can see exactly where the center of each segment's going to go.
Okay, and that's
we'll turn the light off in the machine. That's fancier, isn't it? More laser flashes. That's what we came to see.
Exactly. So it's doing the same type of thing. Obviously, it's just finding a surface where it can mark and internal ring.
Yeah, we can set it to internal or external diameters, because it's obviously going to do its segments in the opposite order to go inside, because they're kind of inverted. I've explained that terribly, but I think you kind of get what I mean.
Yeah, which way it needs to rotate. Yeah. Done again. Very quick. very quick.
There we go. So let's have
I think we can actually see that in the chart
fixture.
Yeah, maybe back a little bit. Johnny.
Yeah.
Yeah, we should have. There we go. Yeah. Well, we can kind of see that.
So there's a little bit of dust and debris in there. So if I just give it a very, very quick wipe just to take the excess dust off, we should be able to see into there.
So again, very fine detail with this as well. So what type of
Why did you pick a shiny material for this green?
Well, unfortunately, metal. It usually happens, doesn't it?
Absolutely, metals are shiny. Hold the press.
There we go. Yeah, we can see that perfectly on the inside, actually.
There we go. So you can see there's no gaps between the segments if we've got it set right. So we teach you what diameter it is, and then from that it can figure out what size its segments need to be to make them line up perfectly. Because if they don't, the human eye is very, very good at seeing imperfections. So if there's a tiny little gap, then you'll see it all day long. And if there's too much of an overlap between the segments, you'll see the double processed area really blatantly as well. So we just need to ever so slightly overlap it, but the laser's very good at figuring that out.
Perfect. Okie dokie. Right. So I think that's most of what we were going to show on in terms of the actual laser itself. So if there's anything else that somebody wants to see again working on the flat, we can do that in a minute. Again, if there's any questions that anybody has on the Galvo, then please put it into chat. All right, now again, what we'll do is I'll just share this again. And so leading on from rotary, I think that's good. That's a little bit dark, but what we have is launched today, hot off the press, 28th of January 2021. Trotec have announced the engraving of 3D objects with the galvanometer machines. So as you can see there, we can now engrave without the use of a rotary onto curved subjects. So we kind of call it, I suppose, the virtual rotary. So if you imagine bottles or planes or balls and that sort of stuff. So we can explain this, or certainly I can't explain this, but Johnny probably would have a better time explaining it than I can. But we've actually got a video. So luckily our Trotec marketing team have created a video. Now, fair warning in advance that these videos are usually a little bit loud when we play it through this software. So
yes.
just
honestly, drop your volume by like 50% now, because our our promotional videos are pretty nuclear with the audio. So
yeah, so we're just going to run this quick video and we'll be back in about 3 minutes. Excellent. Yeah, so that shows you a little idea. So it's a little bit of a less than 3 minutes, but that shows you the idea of the engraving onto 3D objects. So you don't need a rotary attachment. What we have is in the machine there's a what we call a dynamic shifter effectively, and that changes where the focal point is through the lens, and we match that up with the moper and oscillator, and yeah, you can create you can engrave onto round objects. In terms of the angles, I think it's about 60 degrees that you can get. Sorry, 60 degrees that way, I suppose. And what happens is the laser head goes directly above the object, and then that's how we can see the 60 degrees down, and then it will position itself
around the edge of an object, because the laser just physically can't see any further around than that.
Yeah, no, exactly. Yeah, so again, this is something that's really exciting. Again, we've announced it today, launched it today, and it will be available on any SpeedMarker, I think 700 and up, so the 700, the 1300 that you saw in the video,
Yeah.
1350 and 1600. So again, anything with and what those have is they have a moving X and Y axis, so they can position that Galvo head in the different positions over the bed.
So that's a great point, actually. On the larger Galvo machines, like the 1300 and the 1600, it's not just a fixed head. Obviously, we've talked about Galvos having a fixed head, but we can also have the laser head itself moving on an XY table and really sort of getting around that drawback of the Galvo machines of having a small area, just so you can move it around and just move it over a huge, great patch of work. So the reason that the dynamic virtual rotary is so much faster than working on an actual rotary is because, as you saw when I was engraving the ring, it has to keep moving, doing a bit more, moving, doing a bit more. So it's just taking out all that dead time when the laser's not actually firing. So it's just constantly firing, constantly moving over the workpiece, and can consequently do it in a fraction of the time.
Yeah, no, exactly. It's really good. And so I think in that example, those water bottles, I think it's about 45 seconds per bottle, and I think typically if you were doing it that on a flatbed, it would be at least 3 or 4 times that
3 minutes, I'd guess.
Yeah, no, exactly. So that pretty much comes to the end of the demonstration that we've scheduled or set out. I think we've got about 5 minutes left before the next session starts. So I think I'm just having a look in the chat again. If there's any questions in chat, any questions you have, put them in chat. And again, I think there was one from earlier we'll come back to as well. Scott has asked, have you got any Galvo machines that work with a fully automated conveyor or hopper feeder? So the answer is yes. Again, you mentioned the automated division we have earlier, Jonny, as well.
Yeah, all things are possible. Bespoke systems, inline systems. Galvo lasers lend themselves very nicely to being installed on a pre-existing or planned production line, just as an extra station. They've got all kinds of input-output functionality, so you can tell the laser when the part's ready. The laser will report a finished signal when it's done, and it integrates very nicely with production lines. So, as I say, we do have our own automation division in Germany for custom projects. Although, we're always delighted to also, if you wanted to find your own automation supplier, we're very happy to work with and be the laser partner as part of a bigger project. So all things are possible.
Yeah, exactly. I suppose, Scott, it just depends on what you're after. So I think the answer is get in contact with us, and then we can have a discussion with and try and get a solution for what you have in mind. We've got a couple of minutes left, Jonny. Do you want to just run through the software quickly? Just have a little.
We haven't done
software
market, have we?
No, I think we were meant to, but we never did it. So I think it's worthwhile doing. So if I add this to stream, while you
let me just.
There we go.
Okay, so SpeedMarker. This is SpeedMarker. It's our software for these kind of machines. So as you can well imagine, the area in the middle represents the area that we can hit with our Galvo laser. So as I say earlier, with the depth theta lens, we're not missing out on the bits in the corners. It's a lovely flat field over the entire area that we're working. So we've got our inscription here. This is the data matrix code that we did earlier. So you can see we've got black for our main engrave and red just for the cleaning pass to tidy it all up. How do we set our parameters for it? Got our materials database at the top.
Yeah, so anybody who's used to using our plotters, so the Speedy series, this will look very familiar in terms of the material database. Works in this pretty much the same way.
Very similar to job control in that we've got up to 16 different colors for different parameters on the same job. We've got a list of materials here. So what do the settings do? So we've got power, again, like the Speedies, we're at 100% here. Marking speed, unlike the plotters, is a linear speed on the Galvos just because they're very fast acting. So for marking here, we've got 300 millimeters a second. We can go up to 10,000 if we want to, if you've got a material that's going to work with it. Frequency is enormously important when working with fiber lasers and Galvos in particular, because this function is how much power, well, how we're delivering the power from the laser. So we can either have a small number of very high energy pulses, which would be a low frequency, and 20 kilohertz here is as low as we go. So that's a very low frequency. if we have a high frequency, we're firing the laser more times, but with less energy per pulse. So we'll be putting more heat in, and we might be doing something like an annealed mark if that's the case. But 20 kilohertz is a low frequency, so that's going to have a lot of energy for every laser pulse. So that's going to be quite an aggressive marking setting for that. And we can also set to go number of passes. We can set offsets for focusing, all sorts of stuff in the advanced settings too.
Yeah. Perfect.
So we can also serialize our numbers in this software, so we can bring in data from elsewhere. We can add many different barcode formats, import graphics, bitmap, DXF, PDF, whatever you like, and also some very basic drawing capability too. So it's a nice flexible bit of software. And over here is where we have our axis controls. So if we want to manually or automatically set our position. So this is the Z-axis, so our focus axis, and here is our rotary axis. Just very, very quickly while we're on this, we do have a scripting function over on this side. So if you wanted to do very clever automation work, this is where we do it. So move to this position, wait for this input, do this bit of marking, wait for this, etc., etc. We can do some quite complicated things with this. So it's not everyone needs it, but it's a very useful function to have if you do.
Perfect. I think we've got Brian on to tell us to get everyone. So as much as I know you always you can't really shut up about Galvos.
It is a very interesting piece of software, but not something you're going to get through in the next 60 seconds. I don't think.
No, indeed.
That was brilliant, guys. Really interesting. I hope everybody watching found that really interesting as well. So thank you.